Hello students, welcome to this new lesson. I hope you are also constructing all the projects that we showcased in last sessions. In this one, we'll learn about digital signals using a sensor called door sensor. And of course, we'll also make a project out of it.
First, let's understand the theoretical part of digital signals. A digital signal is a signal that is being used to represent data as a sequence of discrete values. At any given time, it can only take at most one finite number of values. In simple terms, think digital signals as steps of a staircase. You can actually go on step 1, then you will go to 3 and 4 and so forth, so on, right? You cannot step in between step 1 and 2, right? So there are discrete numbers of steps involved in a staircase. So on similar lines, if you see digital signals, then computers work on binary notation, right? 0 and 1. So a signal processing in computer happens either as a switch off, which is represented as 0, or 1, which is switch on. So a wire will have either a voltage or it will not have a voltage. These are the only two states which a computer will have. That's why we call it binary, means 2, 0 or 1. Common examples of digital signal would be digital clock, where your second is either 1 or 2, not like analog clock where your hand is moving in between, so it is also taking values in between 1 and 2 and 3 and so forth, whereas in digital clock it is either 1 and it directly switches to 2, 3 and 4 and so on seconds, right? Similarly, computer systems work on digital signals, that is binary, zeros and ones. A digital thermometer also shows temperature in numbers in comparison to the thermometer which was based on mercury. So these are some of the common examples of digital signals. Now it's time to understand how a magnetic sensor works. It actually has a reed switch inside it. A reed switch is basically a kind of a device which has two poles, like you see over here. There are two poles inside this glass. When the magnetic field is applied to this one, it gets closed, and when you remove the magnetic field, then they are normally open. So our reed switch, when there's no magnet means the other part of it, the one uh, attachment to our reed switch, which does not have the wire, it is taken away from the reed switch, then the connections within the switch are open. So your ground is not connected to this right hand side. But when we bring the magnet close to the reed switch, then this connection gets completed. This is a closed circuit now, and so the current can pass from here to here. So that's about the working of reed switch. Let's understand this theoretical concept by applying this in our project. In here, we will create a door alarm system where the input would be a door sensor and output would be a buzzer, which is our alarm. So whenever somebody opens the door, you will hear an alarm. I would rather request that you pause this video and think and try and create this experiment on your own based on your learnings from previous chapters. I hope you were able to do at least some part of it, if not whole. Even if not, then also don't worry, we'll go through the whole experiment here.
Let's see what components would we need. Well, first is Uno with the cable, then the breadboard, buzzer. You have this buzzer in your kit already. Please note that it has two legs and one is longer than the other. The longer one is for positive and the shorter one is for negative terminal. Then 3 jumper wires, male to male, and our reed switch. This is the magnet, this is the switch. Okay, so let's begin and build our circuit. So if you look at the circuit diagram or the schematic, then based on the schematic, we will first go and connect the ground pin to our breadboard. Here our breadboard has negative line, which is highlighted in blue. We'll connect one at the other end of the ground to the blue line. So now this complete rail is negative. Thereafter, we'll take our reed switch. Please note that you may have to uh, uh, tear a bit of this plastic coating to fit it here properly. Then next is the connection for reed switch. One pin has to go in the pin number 13. So here, because we have configured pin number 13 as input read, right? Read, correct? So this is input, and the other end of the reed switch will go to negative, that is ground. I'll place it properly somewhere. Then we'll go ahead and connect our buzzer. So please note that the longer one is for positive, means this one will get the 5 volts from the pin number 12. I'll place it anywhere it's connecting. I'm connecting positive to point number 10 and negative to 13. Take one pin, one jumper wire, then positive leg of the buzzer is the output pin of Arduino Uno, which means it is 12th pin here. And of course, the negative, which is the ground, will go to the ground. This is the 13th pin for me. So now our circuit is ready. Let's go ahead and test it.
Let's look at the programming side of it. Here, firstly, we are initializing our pins. One is for sensor, another is for buzzer, which is the output. Now, here we are initializing pin number 13 to door sensor because we will be connecting our door sensor to pin number 13 and buzzer pin at pin number 12. Right now, here I am defining it as constant because I do not intend to change them later. Thereafter, I have defined a door state variable which will hold the value, digital value coming in from the sensor. After that, we are we are into the setup function where firstly we'll start the serial which is used to print the messages onto the console from the programmer. It helps us debug actually. Thereafter, I'm setting the pin modes. Now, it is important to note that door sensor is the input and buzzer is the output. So, door sensor is of input type and buzzer is of output type. So, we are assigning the modes. It is important to note over here that door sensor has a special constant being used, which is input pull up. This simply means that there is a pull up resistor connected inside the microcontroller and we are activating that. I'll give you a bit more of details as to what internal pull-up resistor is. So there is a internal resistance connected to the pins in the Arduino. So here we are seeing that the resistor is connected to 5 volt on one end and the other end is on the pin number, let's say 13 here. So when nothing is connected, means the button is open or the reed switch is open, then this resistor will pull up the voltage of this pin to high. So by default, the value of this pin will be high. In a reed switch, when we switch off, when we close the circuit. Then this circuit will get completed and the voltage will be going down to ground because there is nothing, no resistance here, direct wiring. So this voltage will become low. So this is important point to note. Okay. Then thereafter we go into the loop function. Firstly, we are reading value sensor, which will be either high or low. Then we are checking the state. If it is high, which means door is open. Remember in the read switch, when the button is open, means the magnet is away from the read switch, then your voltage will be high by default because the ground is not connected over here. So that means our door is open, and at that junction we want to give alarm. So we are setting digital right to high, which means buzzer will receive 5 volts and will start sounding the alarm. Otherwise, if it is low, which means this circuit would be closed, the ground would be connected, and this point, pin 13, will be at a lower state, and then the logic will come in this section. At this junction, the door is closed and we want to switch off the buzzer. Thereafter, we have added a delay of 100 milliseconds just to give a breather to the microcontroller before next reading. And we'll now connect the Uno using the lead, and I'll upload this program. Thereafter, we'll see how it looks in the real life.
So now I have uploaded the program to our Uno, and the magnet is close to the reed switch, which means the circuit is closed. These two wires are internally connected. And you remember, right, that this one wire of the reed switch is connected to the ground. So the input that pin number 13 is receiving is low. Ground means low. So our buzzer right now is off. Now let's see what happens when the door is open. Means this magnet goes away from the reed switch, right? So let's see what happens. There you go. The buzzer turns on. That means whenever your door will be open, there will be a buzzer. Let's see when we bring it back. Perfect. So now your door is again closed and your buzzer is off.
This brings us to the end of current lesson. I hope you enjoyed as much as I did. In the next one, we'll learn about switch buttons, a few more details about LED and buzzers. And again, we'll learn that through an experiment, an exciting one. So, see you there.